Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. What's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I'm one of the math specialists here at the Learning Liaisons. And I just love what we get to do each and every week, which is spend time with you on a Wednesday night and just go over some problems that that might help you on your math certification exam. It might be stuff that you're struggling with. It might be stuff that you're not struggling with. But it's just a time for us to help build that confidence and competence in you so that you can head into that math exam, whichever one you're taking, with confidence. Because remember, it's not if you pass, it's when you pass. So I live in Central Florida. I am an assistant principal in Central Florida, but I am also a math lover. I love all things math. I tutor math. I enjoy math. I solve math problems for fun. And so I just love being able to help you. And maybe you won't ever become a lover of math, and that's okay. And some of you will. But I just love helping you get that passing score on that exam. As always, in the comment box, let me know what you are studying, what you need help with. I always like to do a next week section. And so here's my next week section. I have some notes from last week with some things that people wanted to see me go over, and they are not included in this week's section, but they will be in next week. So I always like to include a next week section because these sessions are for you. As much as I love sitting here and doing them with you, these sessions are for you. And so they are for me to serve you and help you and us to be able to build the problems around what you are struggling with. So, before we get started, I always like to do a little get to know you. So in the comment box, let me know where you're from, what test are you prepping for, and the get to know you question, what's your favorite season? Winter, summer, fall, spring? I had to think about that for a minute because in Florida, it's summer, 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 and summer, and like a hot week of winter. So my favorite season is probably fall or winter. Maybe it's because I live in Florida, and so it just means that cooler temperatures are coming. But I love the cooler weather. I love the snow. I love the fall leaves. If I could pick any vacation in the world, it would be somewhere with snow and mountains. That's just our passion, and that's what I love. Me and my husband both. I am not a beach girl. I do not like the beach. I like the ocean. Like, I like listening to the ocean, but that's about it. I don't like being sandy. I don't like being hot. I don't like being sticky. It's just not my thing. And some people live for that, and that's okay. So where are you from? What test are you prepping for? And what is your favorite season? And like I said, mine is winter or fall. Like I said, we will go over about 8 to 10 problems. These are pre-K through 12th grade, so you're going to see a little bit of everything. If there's something that you want to see, let me know in the comment box, and I will include it in the upcoming weeks. Let's go ahead and look at problem number 1. Which of the following is not correct? Which of the following is not correct? So in this problem, we see quite a few rational expressions. These are all equations. How do I know they're equations? They all have an equal sign. Each side has an expression, and I try to use as much vocabulary as possible, and I try to relate every single problem that we do to at least as many people as possible. Even if you'll never see this problem on your exam, everybody needs to know what an equation is. Everybody needs to know what an expression is. So I try to at least make each problem valuable to you in some way or another. So which of the following is not correct? What we're trying to figure out is which of these does not create an equal equation. So one of these is not going to be equal, right? And so one way I could do it is I could cross multiply each of these and see which ones produce equivalent sides. If it has a rational expression on one side and a non-rational expression on the other, I can always throw it over 1 and then cross multiply on the side, right? So this would be over 1. Now, undoing all of that so that we can see it, I can already see that this is going to be equivalent. How? Because I can factor out a 5 from this left side, which leaves me with, actually, never mind. I might be wrong in that. I think that that's the one that's not equivalent. Let's go ahead and do this with cross multiplication. Then I'll show you where I was going with that. So let's go ahead and cross multiply this and cross multiply this. So we have x times 3x plus 3 equals 3x times x plus 1. Distribute, distribute. You're not distributing this x all the way through to the other side. You're only distributing it on the side that it exists with the equal sign. So this equals 3x squared plus 3x. And this side equals 3x squared plus 3x. So this is equivalent, which means it is correct, which means it's not my answer. Let's go ahead and do this one over here. X plus 2, x minus 2. One times x squared minus 4, which I know 1 times anything is itself, so that's just going to be x squared minus 4. And I know that this side is going to be x squared minus 4. How do I know? Because this is called difference of perfect squares. If you don't know that and you are taking the 6 through 12, 7 through 12 exam, that's definitely something you're going to want to know. Difference of perfect squares. When I distribute that out, so when I multiply x times x, I get x squared. X times negative 2x is minus 2x, but then positive 2 times x is plus 2x, so those end up canceling out. 2 times negative 2 is negative 4. So the first two end up giving me x squared, and the last two end up giving me negative 4. So this is correct, which means it is not my answer. C, if I do this over 1, I end up with 5x plus 5 because let's write it out actually. And I'm going to do it not with pink because I want to do a different color for all of these. So 5x plus 5 times 1 equals 5 times 5x. 5x plus 5 equals 25x. There's our answer. And I'll show you where I was going at the beginning of this problem. And then if I throw this over 1, I have 4x squared minus 25 equals another set of difference of perfect squares. And with difference of perfect squares, I know that I can just multiply my firsts and my lasts. So 4x squared minus 25 equals 4x squared minus 25. So that is not the correct answer either. Now, where was I going with that first problem? Where was I going, or with really letter C when I first started explaining it? I immediately saw that each element had a 5, right? I immediately saw that each element had a 5, which meant that I could factor that 5 out. But I made the quick mistake of doing it too quickly. And so by doing that, what I thought I could do, and probably the error that they were expecting people to make, was that I could factor that 5 out, and I end up with x over x equals 5, and x over x is just 1, and that would cancel out. But I neglected to remember that this would be x plus 1 when I factor that 5 out. So if I factor the 5 out on the top, I'm left with x plus 1 over 5x, and then these 5s cancel out. And so I'm left with x plus 1 divided by x equals 5. That is not the same thing. That is not an equivalent expression, right? And so that quick error would have cost me the answer to this problem, right? And so it's important that we are cautious when we're solving problems like this. And so by doing that cross multiplication method, it verified what my intuition was, which was not correct at first. All right, let's move on to problem number 2. A second grade class creates the bar graph shown using data from a class poll about favorite fruits. Once the graph is displayed, the teacher asks students to make inferences based on the information in the graph. Which of the following student inferences can be justified by using the information in the graph? A, 30 students in the class participated in the poll. B, students who like apples don't like bananas or grapes. C, some students didn't choose a fruit because they prefer vegetables. Or D, more students chose grapes or kiwi than chose apples or oranges. All right, so this is an interesting problem. This is an interesting problem because this problem is not asking us to solve this. This problem is asking us to look at student inferences that indeed can be justified using the information in the graph. This is asking us to use student inferences. So these are all student inferences on the information. Now I'm going to get on a little soapbox here for a minute, and this is going to tie right into that like pedagogy piece of the assessments that sometimes exist. It doesn't exist in the GK or the Praxis core, but it does exist in most of the content teaching nowadays. Most of the tests have changed to include some sort of teaching pedagogy. And so when we're looking at a math problem, we want to offer the ability for all of our students to be able to enter that problem. And so even if we know that we have students that are struggling with the content, we want to create opportunities for everybody to be able to access the problem. So by asking students to make any inference about this graph It allows all students to enter in without having a foundation or a solid understanding. They can make a conjecture. They can make a guess as to what they think is happening. And so looking at this, one student said 30 students in the class participated. Well, we can look at this and say, this is favorite fruits. So if I'm asking for your favorite, then you can only choose one. Well, I have 12 plus 15 plus 8 plus 10 plus 7. How did I know that? Well, if this is 9 and this is 6, then this-ish would be 7 and this-ish would be 8, right? 9, 10, 11. So if I strike this across, that's about 10. This is 8, and this is going to be 1 less than 8 at 7, right? And so all of that can help me understand this. Now, when I add all of those together, 12 plus 8 plus 15 plus 10 plus 7, 12 plus 8 is 20. 20 plus 10 is 30. 30 plus 15 plus 7, 30 plus 15 is 45. 45 plus 7 is 52. So there's 52 favorite fruits. Students who like apples don't like bananas or grapes. Can we assume that? No, we can't assume that students who like apples don't like bananas or grapes. Just because they like apples and the apple is their favorite doesn't mean that they don't like the others. Some students didn't choose a fruit because they prefer vegetables. We don't know that. We don't even know if some students didn't choose a fruit because we don't know how many students were surveyed. If it said 70 kids were surveyed and these are the results, then we could maybe make an inference that maybe some of them didn't choose because they prefer something else. Maybe some of them didn't choose because they didn't like any of those fruits. There's a lot of reasons. And so without more information, we can't justify that inference. It doesn't mean that that inference is wrong. We would just have to gather more information, but it cannot be justified with this information. More students chose grapes or kiwi than chose apples, or it should just say apples. More students chose grapes or kiwi than chose apples. That is correct. 10 plus 7 is greater than 12. So that inference can be justified with our graph. I know that I read apples or oranges at the beginning because I thought that that's what the problem was supposed to say, but then I realized it's supposed to just be apples. So more students chose grapes or kiwi than chose apples. That is correct. And now if it said more students chose grapes or kiwi than chose apples or oranges, that would not be correct. And then we wouldn't have a correct answer, right? And the goal is to have a correct answer. So that's why more students chose apples or kiwi than, more students chose grapes or kiwi than chose apples is the correct answer. A store owner wants to set up a rectangular sale zone to display sale items on the pavement outside of his store. He will use one side of the building, which is 35 feet long, as part of one side of the display area. He will use 210 linear feet of fencing material to fence in the remainder of the display area. Let X represent the length of the side of the rectangular sale zone, which is opposite the building. Write a function that expresses the total area of the sale zone in terms of X. So sometimes when they say in terms of, it means that we not sometimes. It means that we want it to, the area to equal something, something, something with that X value. However, sometimes it's easier to create some other equation and then solve it, right? So let's take a look at this and not worry about the formatting yet. So a store owner wants to set up a rectangular sales zone. So I'm going to set up a rectangular sales zone. Sales zone. To display sale items on the pavement outside his store. He will use one side of the building. So let's call this the brick building. And it's 35 feet long as part of one side of the display area. He will use 210 linear feet of fencing material to fence in the remaining of the display area. So from here around is 210 feet. Let X represent the length of the side of the rectangular sale zone, which is opposite the building. Write a function that expresses the total area of the sale zone in terms of X. Now, I'm just realizing that he will use one side of the building as part of one side of the display area. So when I drew my original picture, I missed that this is only part of one side of the display area. So I actually need to redraw this a little bit differently because it's only a part. So what it actually looks like is something more like this. And then the building is here, which is 35 feet. And then the fencing is here. And that equals 210. And then this equals X. And they want to know the area. Right? So let's call that length and let's call this width. So I know that perimeter equals 2L plus 2W, right? Like, let's start with what we know. And I know if this is X, this side is X minus 35. And then the other side is W and the other side is W. So I know my perimeter is going to equal W plus X minus 35 because I took this side and this side and this side and this side, right? And I know my perimeter is going to be 210 plus 35. Are we in agreement? Because the perimeter is the purple plus the brown. And why do I need that? Because eventually I'm going to have to find this total area. So 210 plus 35 is 245 equals 2W plus 2X minus 35. Add 35 to both sides. 280 equals 2W plus 2X. Are we following? Now, my area. Area has to equal length times width. Agree? Area has to equal length times width. And we want it in terms of X. Agree? So if we want it in terms of X, then we can do area equals length times width. I need to put this W in terms of X so that I only have one variable. I need to put the W in terms of X so that I only have one variable. So now I need to manipulate my perimeter formula to account for that W. So I know that 210 equals X plus W plus W. And then this little piece is X minus 35. So if I add 35 to both sides, then 245 equals 2W plus 2X. Now I'm just spinning in circles right now. Now I'm just spinning in circles. So here's what I'm going to do. I know that my answer is not A. Here's why. I know my answer is not A because if my area is in terms of X, then that means that this is going to be in terms of X as well. It's going to have some sort of X. And some sort of X times some sort of X is going to give me some sort of X squared. Are we in agreement? We're going to end up with some sort of X squared. I also know that if I'm doing something times something, right? Some sort of X times some sort of X, I'm going to end up with some sort of X squared. I'm resharing my screen here. Some sort of X times some sort of X equals some sort of X squared. Here we have 245 divided by 2X plus X squared, 243 divided by 2X squared, and 245 divided by 2X minus X squared. If I had to guess, I'm going to guess that it's not going to be 243 because everything that I've been dealing with is a 245. Could I be wrong? I could be. Here's what I'm going to do. I'm going to table this problem until next week, and we're going to finish solving it next week. Now, if you are an overachiever and you solve this before me, like when you have your own off time, I have a high five for you. I wish I could give you like a Starbucks gift card or something, but I have a high five for you. But sometimes the math whiz gets stuck herself. And so this is just proof that if this was the problem I was doing and I got this far, I would choose between B and D. And if I had to choose, I would choose D. Only because I've done problems like this before and it usually ends up with some sort of subtraction symbol. So it's just patterning, which is why it's important to practice a variety of problems because sometimes that patterning can come in handy. However, I am going to solve this problem next week so that we can be sure of what the correct answer is. Moving on to problem number 4. What is the value of X? What is the value of X? So in this situation, we know that this right here, this shape is a quadrilateral. Everybody should know that. Quadrilateral. How do I know that? Because it has 4 sides. 1, 2, 3, 4. And honestly, it should have different sides because none of the angles are the same. Now, I know that this is a quadrilateral because it has 4 sides. Everybody should know that. But how am I going to figure out what X is? I cannot assume that this is a 90-degree angle or an 80-degree angle or almost a 90-degree angle because 9 times out of 10, the images and the diagrams are not drawn to scale. So in this situation, I'm not going to assume that. I know that a quadrilateral, the angles are going to equal 360 degrees. How do I know that? Well, if I forgot my sum formula, which the sum of angles in a polygon equals n minus 2 times 180 degrees, where n is the number of sides in your polygon, which is your shape. So n minus 2 times 180. In this case, I have 4 sides, so I would do 4 minus 2 times 180. 2 times 180 equals 360. However, here's a little secret. This type of formula is something I don't typically hold in my head. Why? Because I don't feel like holding formulas in my head that don't matter. I mean, it does matter, but I don't like to hold formulas in my head. And so with that said, I know that a square or a rectangle is a quadrilateral, and all quadrilaterals are going to have the same sum of angles. So this is 90, 90, 90, 90. 90 times 4 equals 360. So that's sometimes how I remember it. Now, with that said, I know that 130 plus 55 plus 70. 130 plus 55 plus 70 equals 255, and I'm just going to cross-check that with my calculator. 255. Now, if I subtract 360 minus 255, I get 105. What does that mean? What does that mean? That means that this angle is 105. And I should have had E 105 because some of you would have chosen that. That angle is 105. That's not the angle they wanted, though. They wanted X. So how am I going to solve for X? What do I know about a straight line? A straight line equals 180 degrees. So if this is 105, then this is going to be 180 minus 105. And 180 minus 105 is 75. Questions about that problem? All right, let's go ahead and move on to the next one. All right, this one we already did. What is the perimeter of the shape below? What is the perimeter of the shape below? All right, we know that perimeter means linear distance around the shape. So if I walked from here to here to here to here to here to here to here, that is my perimeter. Now, this takes it one step further because we have variables involved, right? So I know, and I'm going to do each of these in a different color. We've got this side. We've got this side. We've got this side. We've got this side. We have this side. And we have this side, right? So I know I have x plus 1 plus 4 plus blank plus blank plus 2x plus 6 plus x plus 11. Now, what I'm going to do is I'm going to add together the things that I already have. So I'm going to add together my like terms. I can only add together things that are alike. So my x's I'm going to add together. And then my non-x's I'm going to add together because none of them have variables. So x, 2x, and an x is 4x plus 4, 5, 6, 7, 8, 9, 10, 11. 11 plus 11 is 22. So 4x plus 22 plus orange plus brown. by just doing that, what did I eliminate? By just doing what I just did, what did I eliminate? A. Because no matter what I add here, if I only add x's or I only add constants, it doesn't matter because this is larger than this and this is the same as this. So no matter what I add, it's going to be greater than the answer that they already gave me. And so A is out. So now I have a 25% chance of getting it right? Or a 25% chance of getting it correct because I've eliminated one answer. So now I have three shots or 33. Wow. I have a 33% chance of getting it right because it's a 1 out of 3 chance. So I have a 1 out of 3 chance of getting it right. Now, how do I figure out what those equal? Well, orange is going to equal gray minus pink. Do you agree? Let's visually look at this. If I made this into a full rectangle, yes? Like this whole thing was a rectangle and we didn't have this weird cutout. Let's pretend. Then this missing piece right here would be this whole thing minus the pink. Wouldn't you agree? Now, if you're having a hard time visualizing that, do it with real numbers. Let's say this is 4, this is 12, and this is 7. If that's 7, then what is this? 5. Now, this is clearly not drawn to scale, but sometimes when we do it with real numbers, we can see why. Oh, because this whole distance is 12. So if that's 12 and this is 7, 7 plus 5 is 12. Not drawn to scale, clearly. But that kind of helps me solve some of these problems sometimes as I create like a miniature problem that mimics the problem that I'm working on with real numbers. So gray minus pink equals orange. 2x plus 6 minus pink is the orange. Now, why did I put that in brackets? I put that in brackets or parentheses because I'm subtracting that entire thing. So that subtraction sign needs to distribute. So I have 2x plus 6 minus x minus 1. 2x minus x is x. 6 minus 1 is positive 5. So this equals x plus 5. Are you following? Then brown, x plus 11, x plus 11 minus 4. Are we in agreement? X plus 11 minus 4, because it's this whole thing minus that smaller chunk. So x plus 11 minus 4. 11 minus 4 is positive 7. So this is x plus 7. Going back to our addition problem, 4x plus x is how many x's? 6x. 22 plus 5 plus 7. 22 plus 5, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Yes, I still use my fingers sometimes. It's a reliable method, y'all. C is the correct answer. Questions about that? That was a fun one. I enjoyed that one. All right, let's go on to the next problem. Don't forget, if there is something that you want to see me go over next week or in the upcoming weeks, I can't promise that it'll be next week, but in the upcoming weeks, don't hesitate to ask and I'll add it to my upcoming sessions. All right, let's go ahead and move on to the next problem. All right, taking what we just did to another level. What is the value of x if the perimeter of the shape shown below is 60? What is the value of x if the perimeter of the shape below is 60? All right, so I'm going to copy all of my notes from here because what I don't want to do is redo a problem for you guys. That we've already done, right? So I'm going to, there. That's pretty impressive, honestly. All right, so I don't want to redo it. We've already found the perimeter. The perimeter is 6x plus 34. We've already found the perimeter. So then the next step, if we've already found the perimeter, equals perimeter. If the perimeter is 60, then I can just solve this moving forward. So 6x plus 34 equals 60. And then I literally just solve it. I'm going to move it up a little bit. So 6x plus 34 equals 60. Subtract 34 from both sides to make it even. 6x equals 26. Divide both sides by 6. X equals 26 divided by 6. 6 goes into 26 4 times, but not an even 4, so I don't even need to finish that. How come I don't need to finish it? Because that's the only answer that's 4 point something. 6 times 4 is 24. So because it's not an even number, and I know I'm going to have a decimal, I don't even need to finish that because I know it's going to end up being 4.3. Questions? All right, let's keep going. Two rectangles are drawn on the coordinate plane. The vertices of the first rectangle are -4, 1, -1, 1, -1, -4, and -4, -4. The vertices of the second rectangle are 1, 2, 6, 2, 1, 5, and xy. Find the value of x and y that allow these two triangles to be congruent. All right. So if you have grid paper, which 9 times out of 10 you do, then this problem is really quite simple because you can go ahead and grid these out and it makes it really easy. So I'm just going to assume that we all have grid paper. And if you don't, I would suggest getting real good at doing these kinds of grids, because it's truly the easiest way to do this. -4, +1. -1, +1. -1, -4. -4, -4. So here's my rectangle. And then the other rectangle is over 1 up 2, over 6 up 2, 1, 2, 3, 4, 5, 6 up 2, over 1 up 5, 1, 2, 3, 4, 5, and x comma y. Find the value of x, y that allows them to be congruent. Honestly, find the value of x, y that makes this a rectangle. There really isn't a, like, this is kind of redundant because if I put my dot here, it's not going to create a rectangle. If I put my dot here or here or here, those aren't going to create rectangles. So find the value of xy that makes this a rectangle. The only value would be here, which would be, how far over was this dot? 6. How far up was this dot? 5. So it has to be 6, 5. There is no other option. Now, if it said find the value of 2 vertices that make these rectangles congruent, then you would actually have to count and measure. So then I would know that this is 3 long and that this is 1, 2, 3, 4, 5 wide. And then I would have to do a little bit more measuring. But in this case, if they gave me 3 of my points, then it's real easy to find that 4th point because they've already framed out where those 90-degree angles are going to be. And so it makes my job a little bit easier, right? All righty. We have another problem that's kind of like this one. So let's go ahead and look at it. A rectangle is drawn on the coordinate plane. 3 of the vertices of the rectangles are -4, 1, -1, 1, and -1, -4. What is the area of the rectangle? So again, I'm going to copy and paste what we've done here and bring it over so that we don't have to redo the work. And we don't need these, we don't need these rectangles. We only need this one. Now, what is the area of the rectangle? When I was solving the problem before, then I ended up showing you that I counted 5 and 3, and 5 times 3 is 15. So the area is 15. Now, what if you weren't confident in that? Like, what if you were like, man, I'm not confident in my ability to like draw this grid and make it accurate? Then in that case, we can do a little bit of like a modified distance formula. And let me show you how we're going to do that. I'm going to look at how high this, and I'm going to change pen colors here for a minute. I'm going to look at how high this dot is right here, either of these dots. Both of those went up 1, right? And then this one, how high is this one? It went down 4. So we went up 1 and down 4. What is the distance between those? What is the gap between those? 1 minus -4 equals 5. So there is a distance of 5 there. There is a distance of 5 there. And then here we can do the same thing. How far over did we go? -1. How far over did we go? -4. So -1 minus -4 is a +3. That gives me a distance of 3. So 5 times 3 is 15. All righty. We are going to stop there for today, but don't hesitate. Whoops, wrong button. Don't hesitate to find me on our customer hub. Don't hesitate to tag me and let me know, or comment on this video and let me know, what do you want to see me go over in the upcoming week? What do you want to see me go over in the upcoming weeks? I already have some things on my list from last week on my Facebook post that people said they wanted to see. So I will definitely be going over those, but don't hesitate to ask. That is why we're here. I am here to serve you and help you. That is why we are here every Wednesday with the Learning Liaisons. I look forward to seeing you next week. Comment and let me know what you want to see from me, and I'm going to turn it back over to Dr. A. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SYNC35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.